I just wanted to describe a special case of motion, and this is the situation of free fall under gravity. The idea of gravity is that if we're assuming that we're fairly close to Earth, and I realize that if you've been in a physics class where you've solved problems in astronomy, the assumption about being close to Earth doesn't apply. But if we are very close to Earth, what we assume is that gravity acts with a constant acceleration on an object, and specifically, it's a constant acceleration downwards of about 10 meters per second squared or 32 feet per second squared. So when you see, if you've solved these problems, and I know many of you have taken a physics course where you've solved problems like that, you often see numbers like -16, -32 appear in the problem, and this is where they come from. So anyway, you may have seen this equation, which is that when an object is falling under gravity, its position at a time t is equal to s0, in other words, its initial position, its initial height, plus v0t, where this is the initial velocity, that's velocity, I'll write velo, minus 1 half gt squared. And one of the things you'll notice about this is that this equation behaves exactly the way you think it should. In other words, if I want to know what is the velocity at time t, that's just going to equal the derivative. I'm calling this h, but it's really a displacement. It's just sort of like a vertical displacement like that, telling me how high up the object is as a function of time. So the velocity at time t is equal to the derivative of the displacement. We know that. Since s0 is a constant, its derivative is 0. The derivative of v0t with respect to t is just v0, and the derivative of 1 half gt squared is gt. So that equals v0 v0 minus gt, which makes sense because we start with some velocity upward, and gravity is causing the velocity to drop, eventually, dropping it down to 0 and eventually giving it a very strongly negative velocity. So as time goes on, and then the acceleration is just going to be the derivative of the velocity function, or the second derivative of the height function, and that's going to be the v0 is a constant, so that's going to be 0, and the derivative of gt with respect to t is just g, so that's just going to be negative g. And that's exactly what we expect, which is that assuming that motion is counted in the positive direction, gravity is always accelerating the object downward at a constant rate of g. I put here that the rate of acceleration is about 10 meters per second. You might know it as 9.8 meters per second squared. You might know it as 9.8 meters per second squared. So this is an approximation, but that's what we call g. So let's just do one problem, not a very difficult one, just to set this up and show the context. If we throw a tennis ball upward at 5 meters per second from the top of the building, what is the ball's height at t equals 3? We know is that the height as a function of t is s0 plus v0t minus 1 half gt squared. And what we can see is that this is v0. This is the initial velocity, and this is s0, the initial position. So this is going to be 100 plus 5t minus, I've said we can use 10 for g, so that's going to be minus 5t squared, like that. Okay, and of course we can also ask questions such as, I'll just ask an additional question. What is the velocity at t equals 3? Well, we just find the velocity function, which is going to be, that's going to be the derivative of the height function, which will be 100 is a constant. That's going to be 5 minus 10t. That's the derivative of this expression. So, sorry, that function. So that's going to be 5 minus 10 times 3, or sorry, let me be more precise about what I'm solving here. I want to find the velocity at time 3. So that's going to be 5 minus 10 times 3, which is 5 minus 30, or negative 25 meters per second. So in other words, the object is traveling, after 3 seconds, the object is traveling downward at 25 meters per second. And that makes sense because I threw it upward at 5 meters per second, but gravity very quickly acted on it and caused it eventually to stop, turn around, and start falling down.